Okay, good afternoon. Thank you for joining me. My name's Elton. I work for Docker. I'm going to be talking to you about Linux and Windows containers, a hybrid cluster where you can run Linux applications and Windows applications together and treat them and monitor them all in exactly the same way. So this is what I'm going to talk about. I'm going to start by talking about why containers work for different operating systems, why you can't just take a Linux container and run it in Windows and vice versa. I'm going to talk about why you should think about cross-platform applications. If you're from a traditionally Windows background, what there is in the Linux world that makes it desirable to go and learn about some of this stuff. And I'll be showing some demos about a hybrid swarm, a cluster with some Linux and some Windows nodes, and show you how you can run those applications and treat all the components in the same way. So I'm not going to be talking about anything other than Docker Swarm. If you're familiar with the schedulers, if you're not, you'll soon find out what that's all about. If you are familiar, I'm not going to be talking about the other major schedulers, Cube or DCOS, because they don't support Windows at the moment. So they will soon, and all the stuff I'm going to talk to you about is going to be portable between the different schedulers. Probably early next year, Kubernetes will have full Windows support. DCOS, a little bit later on maybe. But the work that you do in moving to Docker is portable. So the idea that I'm going to show you stuff on Docker Swarm, I'm going to be running containers from images, and you'll be able to run those on different schedulers too. Okay, so before I get too far into this, a quick show of hands. Who was at my session earlier today? Wow, you weren't. What were you doing? No, it's fine, I'm only joking, So this slide is from earlier on today. Very, very briefly, if you're not familiar with Docker, this is what Docker looks like. So if you're going to run your applications in containers, you have, and if this morning's session was too fast, this is a recap. You have your server, you install Docker on it, and everything else runs in a container. Everything else runs through Docker. So I'm going to start web applications, batch processes, and databases, all in the same way. I run them through Docker. The actual processes run on the host. That's important for density and for reasons that inside the container, I've got an isolated environment, but the actual processes are using the compute power from the host. It's the same in the Linux world. I've installed Docker as a daemon, and I run my containers through Docker. The image that has your packaged application has got everything it needs. So your actual server doesn't really need anything except Docker. Okay, that's the 2-second introduction to Docker. Now that's fine for a single server. So the stuff I was showing you today, earlier this morning, I had Docker running in a Windows VM on my Mac. To prove how cross-platform it all is, I'm now using my Windows laptop. It's fine in a single environment, but when you need high availability, that's when you need a cluster. That's when you need a scheduler. So if I've got a server running my web application, that web container will keep running for as long as it needs to keep running. But if the server goes down, it takes my web app with it, and you've lost the availability of your application. If you need high availability, that's when you have a cluster. So you have a whole bunch of machines, you install Docker on them, and then you treat them as a single unit. So instead of saying, I'm going to run this container from my web application image, you're going to say to the whole cluster, I want you to run a service. Here's my image that is the basis for that service, and I want there to be 5 replicas. I want there to be 5 containers all running exactly the same thing. And then the scheduler decides which machine to run it on. So it looks at the capacity of the machine, and it schedules a container to run here if it's got more CPU and more RAM than the others, and it will spread them around for high availability. So if I've got my replica, if I've got 5 replicas in my service, Docker Swarm will guarantee the service level. So if one of these servers goes down and takes a bunch of containers with it, Docker will recreate containers on the other servers to make sure you've got the service level that you want. And as I said this morning, the Docker command line actually talks to a Docker API. And that's the same when you're in swarm mode. So you can have different types of interface. Can you see that? You'll see that better when I get to the demos. You can have different types of interface. You can use the command line, which just talks to the API, or you can have a fully fledged web interface that talks to the API too. So what I've got here is a bunch of Windows servers, and that's fine, but because Docker's cross-platform, I can also mix and match. So I can have a hybrid cluster like this. So I can have some Linux servers and some Windows servers. So why that's important, we'll come to that in a moment. And like I said, Kubernetes will get there. It's not there yet, but it will get there soon. So you'll be able to do exactly the same thing. You're still going to run Docker containers from Docker images, but Kubernetes has a different way of distributing the work. And the same with DCOS. So Kubernetes came out of Google, DCOS came out of Apache, and Docker Swarm comes built in with Docker. They all kind of do more or less the same thing. I'm going to show you Docker Swarm because that's the only one at the moment with Windows and Linux support. and because I work for Docker, obviously. Okay, so the same as this morning, all my demos and all my source code is up on GitHub. This is a different link. All I'm going to do is kind of walk through the list of instructions that I've got there. If you want to, by all means, we can have a race if you've got your environment set up. So the first thing I'm going to do is I've connected to a remote swarm. So if I do a docker node ls, so a different set of commands are available when you're in swarm mode that relate to the cluster. And the first thing I'm doing here is I'm saying, list me all the nodes that are in the cluster. A node is just a server running Docker that's joined the cluster. So I've got 3 here. I've got a manager, and I've got 2 workers. One happens to be a Linux worker, one happens to be a Windows worker. I don't have to guess that because I can find it out by looking at the nodes. So if I do a docker node inspect, it's going to tell me lots of information about that node. A whole bunch of stuff that I'm not necessarily interested in, but it tells me this, which I am interested in. So I know the host name of this machine, which is my Ubuntu worker, and Docker knows that it's a Linux machine. And it knows it's running on x86 as well, which is important because Docker also supports ARM and IBM mainframes. Okay, and if I do the same with my Windows worker, which I think is WN worker 1, then you'll see up here, it knows that it's Windows. So Docker knows some information about the nodes that are in the cluster, like the basic information that will help it schedule things in the right place. The other thing that you get in swarm mode, as well as being able to have the high availability and the failover and all that sort of stuff, the swarm communicates between itself in an encrypted manner. So all the nodes, all the communication between nodes is encrypted, and you can leverage that encryption yourself. So you'll see down here all this stuff about the TLS info. So all the communication between the manager, which is the node that decides where containers run, and the workers, which actually run your application containers, that's all done with SSL. Those certificates are generated by the swarm, and they're rotated by the swarm, and it's basically just kept super secure without you having to do anything much. And you can leverage that yourself. So you can also create something called a secret, and I've got some secrets already stored here. So this morning's session, when I created my database container, I had a file which contained the password, the administrator password in plain text, which I didn't really show that because it's not a great thing to show in a demo. But when you move to production, you've got the ability to put things in a secure storage unit we call a secret. And when you create a secret, you just upload a file, Docker encrypts that, and it stores it among the swarm, and it stays encrypted. So if I look at this and think, oh, if I've got access to someone's swarm, or my own swarm, I can say, look, there's a secret here called, it's an Azure database connection string. So if I have a look at that secret, I can find out the connection string. But I can't. All I can find out is when it was created. I've got a random ID and some labels attached to it which describe who can do what with it. No one can see the content of that secret. It gets delivered around the swarm to whichever nodes need it. So if I have a service that says, when I create this service, I say it needs my Azure database connection string. When Docker schedules a container to run an instance of that service, on the server that's going to run that container, the secret gets delivered. It's delivered encrypted. It's encrypted on the server, and it's only made available in plain text inside the container. So inside the container, that secret is made available as a file. You just read the contents of the file, and inside the container, it's plain text. But everywhere else, it's secure, it's encrypted. No one can see it, not even administrators. You have to be inside the container to see the plain text. Okay, so let's show you quickly how some services look. So if I run this, let's actually use the right command. This is ready for my Mac, and as you can see, I am now running on Windows, so the line endings are different. So welcome to live demo debugging. Let's change those to backticks. There we go. I do take pull requests as well, by the way. So let's clear this, try again. Okay, so the commands this morning were all Docker container run, which is when you're talking to a specific server and you want to run a container on that server. Now I'm talking to a cluster, so I'm going to do Docker service create. Some of the things are the same, so I'm going to detach, which means it's going to run in the background. I'm going to use, I'm going to specify the name of an image to use, which is Microsoft's IIS. I'm using Nano Server, so it's going to run on the Windows node. There's a couple of other things that fit because this is running in a cluster. So I can control how the containers in the cluster talk to each other. And the default networking stack for Docker uses some of the Linux functionality, which isn't fully available in Windows yet. So you can configure things and set things up however you want. And what I'm doing here is I'm saying when containers find each other, use DNS round robin. The reason I'm doing that is because the default doesn't work in Windows. So this is going to be a Windows container, so I need to say that it's going to use a networking mode that Windows understands. And the publishing, I'm publishing port 80 on the container to port 80 on the node that runs this, on the swarm. So I'm just publishing the port, I'm specifying the networking mode, and then this constraint here tells Docker to only run it on a node where the operating system is Windows. Now, I don't need to do that. So when I run this, I could leave that constraint off, and Docker will say, OK, get me the next available node. If it's got capacity to run, I'll try and run the container on it. And if it picks a Linux node, then the Linux container will try and run it, and it will say, that's a Windows image, I can't run it. And then Docker will move on to the next node with capacity, which might be a Windows image. So ultimately, it will run, and it will start in the right place. But if I know it's a Windows image, I can specify this and shortcut that process. So Docker will only run it on a node that's a Windows node. So my cluster is actually running in Azure. So like Docker runs anywhere, it doesn't really matter. It could be the data center, it could be in the cloud, any cloud, laptops, etc. So you can use whatever infrastructure management you currently use. So I've deployed all this with an ARM template. I've got a nice Azure dashboard that tells me what's going on in my cluster. So I can see this is my Linux manager, not working very hard, and Linux worker and Windows worker. Nothing's doing very much at the moment. And I've also got a link here to the load balancer that's going to take me to that node. Okay, so this is IIS running in Nano server on my Linux container, on my Windows container, sorry, in my swarm. So Docker's scheduled it on the right kind of node to run it, and it's spun up, and it's just accessible like any other node. I don't have enough availability in my cluster to scale this up, but if I did, I could add more nodes to my cluster, and I would be able to run several instances of this service, and Docker would distribute the traffic among them. We have, I think one of the biggest customer we know about has like over 600 nodes in their cluster with 3 managers. So your manager is the thing that you talk to, and that's what schedules the work. So when I ran my Docker service create, I'm connected to the manager, and the manager distributes works among the workers. For high availability, you need several managers. 3 is all you really need, and then the rest can be workers. Okay, so that's the basics of what a swarm looks like. So let's cut back to my session here. So that was a Windows container that had to run on a Windows node. So why can't I just run that on any node? Well, it's part of the fact that although Microsoft loves Linux now, they are separate things. Windows and Linux are separate things. And the way that the underlying parts of the operating system that Docker makes use of can't abstract that away. So if I'm going to build an image for a Windows container, I will have in my Docker file a whole bunch of steps to package up my application. And for an ASP.NET, a full ASP.NET application, I'm going to start a Windows Server core, install IIS and all my bits and pieces, and then my web application. Or I'll use an image that gets me part of the way here, whatever you want to do. The output will be an image that is about 12 gig in size because it's got the full Windows Server core. It's got Windows Server 2016 with all the features that you can add. And that's why you can take an application that's currently running on Windows Server 2003, copy the code out, put it into a Docker file, and just have it work in a container. The reason that's why the image is so big is it's effectively the full Windows Server. In the Linux world, I could do something similar. So I'd have a Docker file still. I've got my steps describing what I need to do. So this would be a Java app running on Tomcat. So I start from whichever distro I want. I install the JDK and Tomcat and then my application in. I run the same command, Docker image build, but it has to be on a Linux machine. And the output will be a Docker image, probably 100 megabytes or so. Now, those images are just files, and they work in the same way. So I can share them with a registry, public or private, and the registry doesn't care. So I can have one registry with a mixture of Linux and Windows images in there. When I come to run my container in my Windows world, I do Docker container run, give it the name of the image, and it will start that application in a container. And the container is the isolated environment, but the actual process is running on the host. Okay, fine. So my server doesn't need IIS or ASP.NET because that's all in the image, but the actual processing power to run that comes directly on the host. So if I were to do that and then look at the task list on the server, I would see W3WP. And if I ran 10 containers, I would see 10 instances of W3WP. And it's the same principle in the Linux world. So Docker's running as a background daemon. I run my web application, I would see Tomcat listed. If I did a top on the server, I would see the process, I would see Tomcat listed there. And because of that, I can't do this. I can't take my Windows image and ask a Linux node to run it, because A, it doesn't understand the file system. Like, it can't go into that image and look at it because it's NTFS, and Linux won't understand that. And even if it could look at the files, it's got no idea how to start a Windows service or start a Windows executable at all. So it cannot host that process, just like you can't copy WinWord.exe to an Ubuntu desktop machine and run it. It can't run it. It doesn't know what it is. So that's the basic limitation. But Docker itself is cross-platform, and as I have already been doing, I can manage those nodes from Windows or from Linux. All I've got to do is point my local Docker command line to a remote service, and it will let me manage them in the same way. And that lets you get here. So on all of these machines, I've got Docker installed. I join them into a swarm. I haven't shown you that, but it's just 2 commands. On one machine, which is going to be the manager, you run Docker swarm init, which initializes the swarm. And it gives you a secret token afterwards. And on all the other machines, you do Docker swarm join. And you pass the secret token, and you can make that swarm as big as you want. OK, so why would you want to do this stuff? Why would you want this mixture of Linux and Windows? Well, 3 good reasons. You've got to have 3 things on the slide. If you try and have less than 3, like, you're not a proper presenter. So you've got to think of 3. So the first one is consistency. So if you've got a mixture of applications, and actually bigger enterprises, this is much more common when through acquisition or through experimentation, they've got a mixture of Java apps and Windows apps and Linux apps and .NET apps. They've all got different ways of being managed and stored and built and everything and maintained. If you can bring some commonality across that whole landscape, then you remove a lot of friction points. You bring in a lot of shared knowledge because everyone's using the same tools. The second one is the most boring, but it's the most easy to work out, is cost. If you're running in the cloud and you want to run a whole bunch of machines as a cluster of Docker units, then Linux machines are about half the price. So if you can take some of your components and run them in Linux, or if you can run your managers on Linux nodes and just have Windows for the bits that actually have to be Windows, you'll save a lot. And in the data center too, if you can shift some things from Windows workloads to Linux workloads, you're going to save Windows licenses, and you'll also, because you're moving to containers, you'll be able to consolidate. So you'll be able to shut down a lot of VMs. And the last one, which is probably most interesting to a dev crowd, is the flexibility. To be able to say, there's this great stuff in the Linux world, which we don't really have in Windows. Some of the stuff I demoed this morning, like Nginx, which is a web proxy, it's a phenomenal piece of open source technology. It doesn't work so well in Windows. You can make it run, but it's not really where it's intended to run, because it takes advantage of core Linux features that don't come across in Windows. So being able to choose your own tech stack and then just run things wherever they need to run. OK, so a little bit more detail on each of those. So consistency. If I've got a mixture of Windows and Linux apps, then everything is different for them. So all the scripting and automation, all the tools are different. How I build my applications is different. The packages, which is the output of the build, and the things that I distribute, they're all different. And how I deploy the things is different. And the tool set for managing them, whether I'm on my local machine or in a test environment or in production, they're all different too. So I've got 2 completely different sets of technologies, of toolkits, and knowledge that people have to have. And those things don't tend to cross over. Like if you're a .NET developer and you see a really good component that's written in Java, and you go to GitHub and it says, right, run make this, and I don't know what that is, and I don't want to spend a whole bunch of time learning, I'm going to try and find something else. So if you can move to containers, then all those things that are different kind of get hidden away because you're working at a higher level. So the thing that you're going to script to automate the build and packaging is going to be a Docker file. The Docker file contents might do MS build for Windows apps, and they might use make for your Java apps. But the thing that you care about is the Docker file, and that's going to be the same format for all of them. The output is an image, and the image is going to be the same. So you do Docker image build, you do Docker image push, doesn't matter whether it's Linux or Windows. You can treat them all in the same way. And when you run these things and manage them, you're going to use an orchestrator. And the orchestrator abstracts away whether it's Windows or Linux. It takes care of all that stuff for you. So you bring all this commonality in, you remove all the friction, and you get a lot of benefits of using consistent toolchain. Between teams as well, because all this stuff can be jointly owned by devs, ops, and security. So I said cost is the most boring. But it is really easy to work out. So if you're running in Azure and you're thinking, right, we've got our Windows containers, we're ready to go to production or to a test environment, we're going to spin up a really basic swarm, 1 manager and 2 workers, gives us the high availability. It's going to cost about €1,000 to run that a month using modest VMs. If I can change the managers to be Linux and change the worker to be Linux and shift my workload around, I'm going to save about 1/3. And so it goes on, because actually in reality, you're going to have 3 managers, and maybe you'll have 4 workers. And then it becomes kind of half price to run this stuff in Linux rather than in Windows. And just have the Windows servers for the bits that have to be Windows. So full .NET framework doesn't work in Linux, not going to work in Linux anytime soon. So rather than rewrite all those applications, you can take a similar sort of process that I did this morning, break little features out, and those little new features could be .NET Core running on Linux, or your new UI feature could be Angular running on a Linux Nginx server, or however you want to spin it. And in the data center, well, it kind of depends on your licensing model, but you're still going to have the same approach of cutting down on the Windows licenses. That's why the Windows VMs are so much more expensive in Azure and AWS, is because you're paying for the rental of the VM, and you're paying a component for the Windows license. Okay, so the costing is quite easy to work out. The other part of cost is ongoing kind of maintenance costs. So when Microsoft were looking at Nano Server, when they were looking at this cut-down version of the Windows API, they looked at a 12-month period and to see how many updates, Windows updates, resulted in the machine rebooting. Because if you have to do a reboot of your machine, you have to understand whether the apps running on it can tolerate that, or whether you need to move them off manually first. It becomes a complicated process to deal with a reboot. And what they found was that Windows Server Core, if you run Windows without the UI, because you shouldn't have a UI in your server anyway, then it had 6 reboots over a year. So with the full UI, you're talking about a reboot practically every month. With Windows Server Core, it's kind of every other month. And with Nano Server, it went down to once a quarter. So 6 reboots over the period of a year. Now, if you assume that a reboot is expensive, then over that same 12-month period, the Linux server didn't need any updates that needed a reboot. So if you're not familiar with the world of Linux, Linux servers don't have any UI by default. The core of Linux, the kernel, is incredibly stable. The update packages, there's usually no idea, that there's no default automatic update. Updates are something that you manage yourself. And an update that requires a reboot is practically unheard of. Like the Linux server that's running in my garage has been running for 3 years. The only time it's been rebooted is when there's been a power failure. The actual server itself doesn't reboot because of the software. So there's a kind of hidden cost in there that is also something to bear in mind. And the last one is flexibility. So this is a great slide because it's becoming increasingly out of date. So it used to be the .NET Framework, SQL Server, IIS, these are great tools. Like if you go into a Linux-heavy environment, people sneer at this stuff, but this stuff is great. And it only runs on Windows, apart from SQL Server and kind of .NET. But you know, I haven't updated the slide yet. And they don't run on Linux. But in the Linux world, there's also this great stuff, like Nginx, the web browser, Redis, which is a message queue come database. In the tooling world, there's GitLab, which is like GitHub that you run in the container on your machine. That all runs in Linux, and it doesn't run on Windows. And it doesn't run on Windows because of it taking advantage of key performance features. So with Nginx, when you run a Linux server, you can tweak pretty much everything. Like one of the things you can tweak is how many file descriptors the server will allow to be open at any one time. So how many real or virtual files are allowed to be open. You can't tweak that in Windows. That's not something Windows lets you get at. And Nginx makes use of that to make sure it can open lots of fast access to the files that it can serve. Redis, similarly, it's the message queue. There is a Windows build of it that Microsoft built a couple of years ago, but they haven't maintained it. So Redis has moved on, and the Windows build is still down here. And GitLab uses Nginx and Redis, so it's not going to come into the Windows world until the other things do. Okay, so that's the kind of background of why this stuff's useful. And now I'm going to move on to the demos. Now, if you were in this morning's session, there was a big disclaimer, because this morning's demos, like they were all slick and they all worked fine. The demos here are going to fail because of the nature of what I'm doing. And I think I know all the ways that they will fail, so I'll be able to repair it, but we'll find out as we go on. Okay, so a similar idea. I've got an application that I'm going to deploy to my swarm. It's actually the application that I built this morning. So what it is it's a newsletter application. You can put your details in and get information about a product. There's a proxy at the start, so the entry point is a proxy, and then depending on whether you're browsing to the home page or to the application, it'll go to a different container. So the home page gets served by this container, which is a content management system, and the original application goes here, which is an ASP.NET Web Forms app. When you sign up and click a button, the Web Forms app drops a message onto a queue, publishes an event onto my queue, and then I've got a console application that listens for those events and saves the data in SQL Server. For this deployment, I'm using SQL Azure rather than run SQL in a container because this is a production environment. I'm going to make use of whatever my infrastructure is. If I'm in a data center and I've got some highly tuned SQL Server boxes, I'll use them. And if I'm in the cloud, I can use a managed SQL database. And the containers connect with them just in the same way as any other service would. So what I'm going to start doing is moving some of these things to Linux. So the next release, I'm just going to move my message queue to Linux. So the message queue I'm using is called NATS. It's an in-memory, really performant message queue. Again, it kind of emerged in the Linux world and got brought over to Windows, and it's not quite as performant in Windows. So if I move it to Linux, I'll get better performance, and I'll be able to run it on a Linux server more cheaply. The next one, I'm going to add some more features. So I talked this morning about once you have these integration points, you can break features out and add more stuff to your solution. I'm going to add a reporting database. I'm going to use Elasticsearch and Cabana, which is going to give me a front end. And I've got another message handler that's running in Windows here. So I can do this deployment without damaging the app because everything's going to run in containers. It's going to be an additive deployment. I won't change anything that's existing now. And the final one is to replace the proxy container. So Nginx, as I said, it does run in Windows, but they call it a beta release, and mainly because it doesn't have all the performance characteristics. So if I move that to Linux, then I'm going to be in a much better place. So this is the outcome. The road to get there is going to be a little bit rocky, but you have to bear with me. Okay, so let's get rid of this stuff here. So I'm going to get rid of the IIS container service that I started before because it was using port 80, and I want to use port 80 for my new application. So I'm going to deploy my application as a stack. So I'll get that running, and then I'll talk about what that stack file looks like. That actually says creating, but the C and the R have come off the end. So creating all the services. So I'm using a Docker Compose file, which describes all the parts of my application. But because I'm in a swarm, I don't use the Docker Compose tool. I use the schema, the file format, and it's broadly the same, but the way I deploy it is as a stack. And I'll show you what that means. So here's my stack file, which is, it's just a Docker Compose file, but it's got some extra stuff in there. So I've got my message queue that's currently running on Nano Server, so that's going to run on Windows. And again, I've got those same hints in there that I did when I created my first service. So I'm using this DNS network mode, and I'm giving it the hint to run this on Windows. And it's the same for all these services. So my save handler is the message handler that I built earlier. I'm using the DNS endpoint. I've got a Windows constraint. Hello? I've got one other thing in here. I'm using this secret. So this secret to create my to connect to my database is going to come from the secret that's already populated in the swarm. So I don't need to understand what the actual connection string is to be able to manage this stuff, because that lives in the swarm. So somebody else, an administrator, has got the real password. They go and create the secret. That's gone now. No one else can read that in plain text. But I can refer to it just by using the name of the secret. I've got my CMS container, that's Umbraco. I'm publishing that on port 8088 so that users can browse to that and change the homepage. And that's got the same thing. DNS and mode is Windows. My web application, and that's got the same thing. It's using that same connection string. And my Nginx proxy. So this and the Umbraco endpoint are the only things that are public. And way down here, everything's connected to the same Docker network, so these things can all talk to each other. So when I deploy this in a swarm mode, Docker uses a slightly different type of network called an overlay network. So it's a virtual network that spans all the nodes in the cluster. And any container that's connected to that overlay network can talk to any other container on any other node. So if my proxy is running on one server, it can talk to another container on another server just by using the container name, the service name. So that's what that's going to do. And the last thing, I'm pointing my secret which is how I've defined it inside the compose file, is actually going to be using this secret in production, which is my Azure connection string. Okay, so it's deployed all that stuff. So if I go and have a look at the services, Docker Stack services, build stuff. So it's telling me that all these things are here. There's the home page, message queue, save handler proxy, web, and they're defined without a specific number of replicas. So the default is 1. So there's 1 container serving each of those. So as it happens, they'll all be on my Windows node because they're all Windows containers. Okay, so I've also got a connection. Let me see, let's get this up here. So now when I browse to this same URL, it's going to be my new application. So this is this morning, if you weren't in this morning's session, I did this, everyone went, wow, and everyone went crazy. If you were here, you might not remember that. So this is coming from the CMS. This is coming from Umbraco. So my proxy container has had a request for the home page, has routed it into the CMS container. This is the thing that the business units can own. They can change the UI without needing a release. And when I click this button, this is where I get to my original application. So this is the web forms app, also running in a Windows container. And when I'm going to go back to V1, because this is V1 of session 2, and put this stuff in here. Okay, so when you click go, it drops a message onto the message queue. The message handler picks it up and it puts it in the database, which is going to be SQL Azure database this time. So I can go and look at that. If I have a look at the service list again, I can see my save handler here. I've got 1 replica. Now, I'm actually using Docker EE, the Enterprise Edition, which gives me this fancy UI. So all the stuff I'm showing you works just as well with EE and CE, because that's where you get with Swarm, and you get the command line access for all that stuff. But with EE, you also get this management unit. The reason I'm using this is because it's much easier to see what's going on. So my services here, these are all the services that I've just deployed. And in my save handler, I can go and look at all the containers that are running this service. Now there's 2 here, 1 exited and 1 still running. So if I look at the one that exited and look at the logs and zoom in a little bit, you'll see that a container ran, it tried to connect to the message queue and it failed. And then the program ended. So what happened there is the message queue container wasn't ready. So my console application started. The first thing it does is connect to the message queue to subscribe to events, but the message queue wasn't ready, so it failed. So that container died, which is fine, because now I'm running in Swarm mode. So if that container dies, Docker starts a replacement. So this is why I have this new container, zoom back down, which has now been running. Is that my save handler? Let's go back to my services. So my save handler, 2 containers. The first one died, and then Docker just immediately started a second one. And the logs for that container, I've got it's connected to my message queue, it's received an event for my new prospect, it's signed it up, and I've got my prospect ID of 12. That's the ID that comes from SQL Server. So this has been saved to SQL Server, and also my web application has correctly connected to SQL Server because the drop-down list comes from the reference data in the database. So this stuff is all working correctly, all in Windows. And if I had any sense, I would end now. But I'm going to start moving through, and we'll see how this stuff pans out. So let's go back here. So version 2, I'm going to replace the message queue itself. So what I've got here is I've got another stack file. When I've got my stack deployed, that's a single unit. So when I did Docker Stack services, I can do Docker Stack ls, and it'll show me I've only got 1 stack in there. I can do Docker Stack services. It shows me all the services that are inside that stack. The reason why a stack is important is because that is a single unit that represents multiple things, but Docker understands they're part of the same thing. So when I've got my stack defined with all these things in here, Docker knows that this particular container running on this particular node is part of that stack. And I can manage the things as a stack. So if I now deploy this second file to the same stack, Docker Swarm will do the same thing that Docker Compose does on a single server. It will look at what's currently running in the stack. It'll look at how the definition has changed, and it will make whatever changes it needs to make. So in this stack file, all I'm doing is changing the definition of the message queue. So instead of using the Nano server, the Windows version of NATS, I'm using the Linux version. And again, I've changed the hint to use Linux as the constraint of where it's going to run this stuff. It connects to the same network. It uses the same network discovery, so it will talk nicely with everything that's in there. So deploying this is not actually going to cause any harm to my application. Where have you gone? Come back here. but that doesn't mean that my app is going to be fine afterwards. So what it's going to do is it's going to tear down the message queue that's running on, that says updating, not dating. So it's updated the message queue. It's gotten rid of the Windows container that's running. It's running it's running a Linux version now. It's still got the same service name. So containers can still discover it in the same way, but that doesn't mean the application is going to work. And that's one of the reasons why it's not going to work is because of assumptions that get made with legacy applications. So let's just go and show you this here. So now, if I have a look at my nodes, so this is just talking to the Docker API. So the UI here is just making the same calls that the command line makes. So on my Ubuntu worker, if I go and look at the containers, I've got one container which is my message queue. So it's now created, it's now running in NATs. It's in the same overlay network, so things can still talk to each other. So it should work. Okay, so browsing to my application, this is coming from the CMS, so that's fine, that's all working the same way. If I click on this button, this is going to take me to my web application. That's fine, that's working too. And when I go and submit this, it's going to send a message to the queue. Now the queue is still reachable on the same domain name, on the same DNS name. But when I click go, this may or may not fail. It depends on how long I take to talk in between clicking the button again, whether this fails or not. It looks like it's going to fail this time, which will be good. So what actually happens is this web application, this web forms application, is using a NuGet package which does the message queue stuff for me. There's a message queue client, there's a NATS client in there. Yay! Okay, so there's a NATS client inside my application, which is making certain assumptions about discovery. And you will see this all the time with legacy applications, traditional applications. When I talk to a database, if I'm an old web app, I go and get the database, get the connection string, which contains a server name, I get the IP address of the server, and I store it forever. Because that's my database, it's never going to change. I can store that IP address forever and save the 15 nanoseconds it takes me to look it up. But in the new world, services move around. And especially in containers, because of the self-healing nature of a cluster, if a server goes down, containers will come up somewhere else. They'll have different virtual IP addresses listing on the same service name. So what your application should do is not cache any of that stuff. So you need to turn your DNS cache right down or off, and in your application, you shouldn't be caching the discovery results. But this is an old application, and it has cached it. So it's got the IP address for the Windows message queue, which is no longer there. What it should be doing is coming back to Docker and saying, give me the IP address for the message queue every time. So, and the same will be the case with the message handler. It's listing on a queue that's no longer there. So when it tries to poll it, it's not going to find anything. So in order to fix this, what I do is I go and restart all these services. So by restarting them, I'm going to get a new container which doesn't have an invalid cache, and it will work correctly. So if I restart my web application, that's my web, and again you can do all this stuff through the command line as well. And I'll restart my save handler, and let's have a check that these are all running. So yeah, that's up now. And the other thing that's going to happen is my proxy has got the same problem. So when I start the proxy, it's configured to use container names for the upstream web applications. So it's going to look for a container called homepage, that's still there. It's going to look for a container called web app, which has now got a different IP address because I've just restarted it. So I need to restart my proxy as well. That's why I don't like doing this demo, because it's this is not how you would do it in real life. But actually, it does show that you can get around these problems if this is the type of thing you're gonna experiment with doing. Okay, so a whole bunch of things have been restarted. So now let's see if this works. Okay, so my new proxy can connect to my CMS. And let's see if the new proxy connects to the web application. My new web application is going to start cold, but that's okay. And this is a completely different container now. Someone asked me this morning about containers being transient, the idea that you throw them away and replace them. Yeah, that's absolutely right. So the idea is you don't do any ongoing maintenance to a container. Containers, in this world where you're in production or you're on a cluster, you don't really work with containers unless you're trying to debug a problem like this. So your container is meant to be throwaway. Doesn't mean it can't run for a long time. It can. My web container, that can stay running for months. But what I don't do is connect to the container and try and run Windows Update. or deploy a new version of my application inside the container. Because if I make changes to that container, they're not going to be reflected in the original image. So if I change this container and the server goes down and Docker starts up a new container, it'll revert back to the original image. So that's why you always make your changes in your image, which is automated and scriptable and all that sort of stuff. Okay, so let's see if this works. v2.1. Let's put some stuff in here. Hey, okay, so that's obviously connected to the message queue because I didn't get an error about it not finding it. And so if I go and look at the save handler, we'll see if we've got the data saved. I would go and look at SQL Azure, but unfortunately, the secret password is on my Mac, so I can't load it up without, distracting everyone. Okay, so save handler. Look at my containers. There's the original one that failed. There's the one I've just replaced, and here's the new one. I can go and look at the logs. And there we go. I've got a new prospect ID 13. So it's received the message. It's connected to the new message queue that's running in Linux. It's got the message, and it saved it to SQL Server. So that's all working fine now. I had to manage the fact that the applications were trying to be too clever. They're trying to cache discovery, and they shouldn't. They should let the discovery tool do discovery for them. Okay, so that's the first part. Phew. Let's go back here to my demo. Okay, so I've changed from my original deployment. So I started off with nothing. I deployed everything from my stack that was all running in Windows containers. And it was slightly bumpy, but I've got, oh, wait a minute. Let me go and do the rest of it. So I've gone on to version 2. I've got more to do. Let me show you this, version 3. Version 3, I'm going to add some more features. So again, this is an additive compose file. So all I'm doing is extending what's currently there. So when I run my Docker stack deploy, it's going to look at what's currently in the stack, and none of these services exist because I'm adding new ones. So what I've got here for version 3 is I'm going to run Elasticsearch. I'm going to use the Elasticsearch image that's on Docker Hub. It's a Linux image. I'm going to constrain it to run on Linux, but it's going to join those same networks, and I'll have an Elasticsearch database in a container, which isn't accessible outside of the Docker world, because nothing's being published. And I can also do things like specify environment variables. So if you're familiar with Elasticsearch, it will try and grab as much memory as it can, which is fine if you're doing an intense amount of work. But if you want to, you can constrain it to just have a limited amount of memory. So that all lives in the stack file too. Then I'm going to run Cabana, and Cabana is just a front end for Elasticsearch. This is giving people self-service analytics. So if I made Cabana available to my business users, they could go and find out who has been signing up and all that sort of stuff. So again, it's a Linux image, so it's constrained to run on Linux. It's publishing port 5601, which is the Cabana default port. And then I need something to put the data into Elasticsearch. And I've got another message handler here. So when I talked about this morning, the idea that when you put a message queue into your application, you can start breaking up the back end and running things in different containers and glue them together with the message queue. That's what I've got here. So this index handler listens for exactly the same event. So it will get a copy of the event that the SQL Server handler gets. And it's going to save them in Elasticsearch. So it can do some other stuff. It does a little bit of enrichment of the data and presents it in a slightly different way in Elasticsearch. Okay, so when I deploy this, it's going to do the same thing. It's going to find out what's different, and it's going to just deploy the stuff that's new. Come back here. So let's do a stack deploy. Version 3. And you'll see it's just eating the new services. There's no dating going on here because it's not updating anything. It's left everything that was there because none of those definitions have changed. I've added new stuff. Now you can run, Elasticsearch is just a Java application. Cabana is just a Node.js application. You can run them both in NanoServer. So you could run on Windows containers, but then you're running them in Windows and you don't need to. Like there's no dependency on those applications to run in Windows. So if you can run them in Linux, you get those benefits without having to deal with your own Docker images. The other thing is that the Elasticsearch in Cabana, I'm using the official images from Docker Hub. So that's maintained by a team of people who keep them up to date and keep them maintained. There isn't a Windows version. So if I want to run Elasticsearch in a Windows container, I've got to write my own Docker file. It's not complicated, but it's something that I need to own, which I shouldn't really, because I don't want to own that stuff. Okay, so that's running now. So if I go back here and sign up again, what's this, V3? V3 seems about right. Lithuania. And when I put that in there now. So the behavior is the same. And for the end user, it's exactly the same. And for the operations team, it's the same. So the data is going in SQL Server. Event gets published to the message queue. The SQL Server message handler picks it up and stores the data in SQL Server. That hasn't changed. I've got a second handler listening for the same events now. So that's going to get a copy of those events. And it's going to save the data in Elasticsearch. And that's going to become available in Cabana. Those containers are running on Linux. So if I switch back and look at my nodes, I've got my Ubuntu node here. Now I've got three things running. I've got my message queue, my Elasticsearch container, and my Cabana container. And they can all talk because they're all in the same overlay network. And my index handler that's running on my Windows node can insert data in Elasticsearch on my Linux node. So if I open my Linux node here, this is Cabana. So this is inside my container. Actually, what I would really do if this was really in production, I would put this behind my proxy as well. And in my proxy rules, I would be able to condition who can access this. So I can have an IP whitelist and say you can only access Cabana if you're in the office. And the proxy will take care of all that stuff for me. But just for simplicity, I'm just going to run it directly. So the data is saved is in prospects. Because I've already put some data in there, Cabana finds it and it understands the structure of the data. So I've got all this stuff in here from the message that has been received by the handler and put into Elasticsearch. So when I click on Discover, I can, this is the data that's been put in there for me. So I've got, whereas in SQL Server, I'm just storing the codes and the reference data. In Elasticsearch, I'm storing the real actual data. So if you start doing kind of BI stuff, this actually enables the business to own this themselves. So I won't do it now, but it's really easy in Cabana to build a dashboard with a couple of pie charts that show you which countries people are signing up from and what kind of role they've got, and charts of how many people have signed up over what period of time. It does all that stuff for you. It's really easy to use, and I don't have to own it. I can just give it to some power user in the business, and they can write their own dashboards and share them. And because it's not a critical part of my application, I can run Elasticsearch in a container. Now, I could swap in a managed Elasticsearch service if I wanted to, but for this case, I might only will have to run these reports once or twice a day, in which case I can just run a container, and I can get the density benefits of running everything in the Sword. Okay, so I've got Cabana, I've got Elasticsearch running now, and the last thing is to swap out my proxy. So I said before that this morning I was running Nginx on Windows, and it does work, but it doesn't have the same level of performance and functionality as it does in Linux. Like, it emerged from the Linux world, and it's better off in the Linux world. So if I deploy version 4 of my application stack, the only thing that's changed is the proxy definition, and I've got a new version of my Nginx proxy that's built on Linux. It's going to run on Linux, and it's using the same discovery mode and network, so it will still talk to everything else. So now when the proxy gets a request, it can route it to the other containers, even though they're running on Windows containers. So I'll run this, and then I'll have a look at the configuration file and show you how it's different. So version 4, it's going to update the proxy. Okay, cool. So what I've got in here, and again, this is all on GitHub. If you want to poke around, you can. I've got my Docker file is super simple, because all I'm doing is using the official Nginx build, which is a Linux container, and I'm creating a folder to store some cache items, and I'm copying my own configuration. So whereas the Windows version, I had to install Nginx myself and configure it with a multi-stage build and all that stuff, I don't have to do any of that. I can just use the official Nginx image and add in my own configuration to configure how it works. And my configuration file is a bit more interesting. So this morning, all I had was these location blocks that told Nginx where to route different requests. Whereas now, I can take advantage of all the functionality in Nginx, so I can do a lot more stuff in my proxy. So one thing I'm doing is I'm caching. So I'm setting up my location so that when I browse to the home page, Nginx will cache the response from the CMS container. So the next time I get a request, it'll come from the proxy. It won't go and talk to Umbraco. And the same for my web application container. It's going to cache things for an hour. Whereas in my Umbraco container, I'm caching things for 5 minutes. And what that basically means is when I want to scale up, I just scale up the proxy. I can run a dozen containers with Nginx and one Umbraco container, because Umbraco is not getting any traffic. Like, my Nginx container could be dealing with 1,000 requests per second and serving all of them from its cache. And it would go to Umbraco once every 5 minutes to update the cache, which is obviously really good. And the other thing you get here with Nginx is I can say, if the upstream is offline, if there's a problem with my Umbraco container, serve it from the cache anyway. So I could kill my Umbraco container and it would still work. And some of the other things you can do fancy stuff like you can change, take advantage of HTTP caching, change all the responses, you can do whatever you need to do in Nginx. Yeah. Let's just have one for now. Yeah. So that's just using the service discovery that's in Docker. So Docker service discovery is just DNS.
It's based on hosts definition.
No, it's not using hosts. It's all dynamic. So so in an ordinary world, when your server looks up a domain name, it'll go to a DNS server, it'll get an IP address, and that's what it'll really use. It's the same in containers. So when inside my Nginx container, when it looks for a server called homepage, the request comes to Docker first. And Docker says, that's a container, here's the container IP address. If it's not a container, if that was google.com, it would use the host DNS. So it's just using DNS resolution. No, this is part of the Docker image. So I'm taking this configuration and building it into my image. So what I've got here, this configuration file gets packaged by this Docker file on top of the official Nginx image. So when I build this image, I'm going to have something different. I'm not using the official one directly. What I'm using is one that I've already built and called build stuff -nginx :linux. So whenever I run this, it's already got the configuration built in. There are other ways of doing configuration, but for something that's fairly static, you can just bundle it in your image. Okay, the other 18 questions going to wait? Okay, so now I've got a whole bunch of stuff going on here. So I've got inside my, my Linux node, let's go and have a look. I've moved like half of my application over to Linux now. So I've got a proxy running here, I've got my message queue running here, and I've got my new components, my Elasticsearch and Cabana. So now if I browse here, I'm not going to get any response because there is no longer anything listening there because the proxy is coming from my Linux server. So if I browse to my Linux server, so now this is being served by Linux, being served by Nginx, running on my Linux node. It's going to the homepage container using DNS resolution, getting the content from there, and it's just proxying it. And the same when I click on here, it's going to go back to my original web application. So the behavior is kind of the same, but now I'm using like the real Nginx, the Linux Nginx, and I can scale that up. I can just have more Linux servers, more Nginx containers if I want to deal with a lot of load. Okay, so that takes me back to here. Come back. Okay. So version 1, I started with nothing and I deployed everything on Windows containers. This was the starting point from, which was the end point of this morning's session. And now by now, I've moved, you'll notice that some of these are Windows and some of them are penguins. That's a Microsoft, these are Microsoft images. So I've moved what I can over to Linux containers. So now actually the only things that are running on Windows containers are the things that have to. So Umbraco is an ASP.NET it's an MVC application, but it's deployed, it's full framework. So it has to run on Windows. And the same with my message handlers, and the same with my original web application. Now these are new components, so I could, if I wanted to, rewrite them in .NET Core. And actually for this one, the Elasticsearch would be pretty easy because the dependencies are just NuGet packages that already have .NET Core variants. So I can write that in .NET Core and then run that in the Linux container. But with my original stuff, my legacy application, moving to .NET Core is not necessarily going to be easy. This uses Entity Framework version 5. So if I want to bring it into .NET Core, I have to bring on an Entity Framework upgrade into that project to 6 or whatever. And that isn't necessarily just going to be a recompile. So if I want to leave this here, that's fine. You know, I've got my hybrid swarm will manage all this stuff for me. Okay. So same thing we saw this morning. So this is the modernization spectrum. The idea is you land wherever it works for you. So my original my original .NET application kind of started off here, and I've broken features out and run them in different places. And the key part here is that when I'm in this part, I can renew just the features that are interesting to me. And the hybrid swarm will give me the infrastructure layer to make all that stuff work. And again, the effort that I'm making to bring these things into Docker is not limited to Docker Swarm. So I've talked about Swarm because that's the only thing where you can do this right now. But if you're interested in developments happening in Kubernetes, then you'll be able to do this soon in Kubernetes. And you'll be able to take the same kind of definition So you're going to take a stack definition and deploy that to Kubernetes using Docker. Or you can write your own. Kubernetes has a similar but different way of describing things. You can describe it with Kubernetes YAML files, but use the same images. So when you start moving things to Docker, most of your effort is about writing the Docker file, getting your application working in a container, and getting it connected to other containers. That stuff works no matter what orchestrator you're using. So you're not being limited to just the Docker stack. Okay, so some more links there. Oh, that's really old. That's from last year. No, that's right. No, that is right. So these are the videos. These are the videos from DockerCon. So we have two big conferences, DockerCon US, DockerCon EU. This was last month in Copenhagen. All the sessions are on YouTube. You can go and watch them all there. If you want to play with some stuff yourself, with some Linux nodes, then this URL takes you to a site called Play with Docker, which is an online playground. You don't need a Linux machine, you don't need Docker installed, you just need a browser. And there are a bunch of labs you can follow through to look at how this stuff works in Linux. And if you're interested in what's happening with Docker and Kubernetes, then that link will take you there. And it'll tell you how we're bringing Kubernetes into the Docker platform, but it's the real Kubernetes. We're not doing a fork. And there we go. So any questions? Ah, you again.